In this video, we'll see how we can review a model in Catia. This video will be helpful for the person who have maybe no idea on Catia and would like to do a review, or a person who's a quality engineer who have to do monthly audits or quarterly audits on projects which involves deliveries that are done using Catia. Let's just have a look at what are the topics covered. Firstly, I'll be talking about the introduction to Catia tool, where we'll be talking about what was Catia before and how what is Catia now, what's the full form of Catia and things like that. And then we'll be seeing how we can use the mouse to navigate the model. And then we'll be talking about the specification tree and toolbars, where specification tree is one of the important component that you need to understand in Catia, so that you understand how a model is evolved and things like that. And then we'll be talking about checking parents and children of a feature, where we look at a feature or we look at a geometry, and then we'll see what are the dependencies, and if we delete this, what goes, and to create such ideas. And then we'll be talking about checking constraints over under constraint sketch, where we'll be talking about what kind of a sketch it should be, and if it's not a properly constrained sketch, what happens and what are the consequences. Then we'll be going ahead with inserting a component on an assembly, and then changing graphic properties of one of the product or both the products, and why we are changing that, and how do we superimpose identical models, and how we can check the interference, and taking the section views. So let's just go ahead and go to the introduction of the tool. So Catia, the full form of Catia is computer aided three-dimensional interactive application. As you can see, the first 5 letters of this words are bolded, and if we take one of them, CATIA, that's Catia. Now the industry is mainly used in aerospace, automotive, and shipbuilding, and it's also nowadays it's also used in architecture. I personally have worked in one of the architectural projects where we were using Catia to build all these curved structures and curved surfaces, which was used as components in an architectural building. Now this started in 1977 by avionics Marcel Dassault, that's the person's name, and he wanted to develop the Dassault's Mirage fighter jet, and that's how we started with this application. Initially they named it as CATI, conception SST three-dimensional interactive. That was what it was called, and that's the French for interactive aided three-dimensional design. So later, as this software was very useful, they started developing the software in a way that they can give it outside to different companies to do some kind of CAD activities, as we are doing now. Now as we move ahead, we'll be talking about the navigating a 3D model. So let's open the model here. So I'm just going to open the screwjack model. Now we have 2 models that I prepared to present in this presentation. So I'll talk about C1 screwjack. C1 means that's configuration 1 screwjack. I'm just going to pull the assembly over here, and that assembly is going to load. When it comes to Catia model reviewing, the most basic thing is to understand how a mouse works. So as we see over here, to pan, we have to click the middle mouse button and move. So let me just try that, middle mouse button and move. You can see that it's panning. In this case, it doesn't, at this particular view, we don't need to pan it much, because the model is already over here and we don't have any models or anything over here. But if we are like pretty inside, we are somewhere over here, and if we would like to see the other side of this circumference, we can just move it like this, and that's how we can use a pan over here. Now let's just move ahead with the rotate. So we can rotate is middle mouse button and right click. You can see that it's getting rotated. Now if we, one more thing is zoom. So how to zoom is press the control key and middle mouse button, and you can zoom it and zoom out. And I would like to also discuss some tips over here. Quick zoom in and zoom out. So how we can do that is, while we are rotating, we can just release the right click so that we can zoom it without using the keyboard. So before we were zooming using the control key and middle mouse button. Now I'm using middle mouse button, right click to rotate, and leave the right click so that it's getting zoomed. So in this case, the middle mouse button need to be pressed. So basically what you can do is middle mouse button, right click, leave. Then it's becoming like zoom in and zoom out. So in this way you don't have to use the keyboard, and you can just continue using the mouse. Now teleport. So this is also an important option when we are working on a large model. Let's say that we have like a big structure and this is just a small part of it. What we do is use a shift key and draw a circle using the middle mouse button. You can see not the circle, like a rectangle, and once you're done, just leave. So it just zooms into that particular rectangle that we have created. What we can do that is shift and middle mouse button, move so that a rectangle is created, and leave so that it just zooms inside. In the other case, we'll have to, we have to zoom in and zoom in and zoom in and all that. But when we are working on larger designs, it's more effective that we use this kind of tricks and tips. Let's just move ahead and see what's over here. Common issues faced by beginners. So what I've mentioned is switching between specification tree and 3D model space. I'll be talking more detail about the specification tree, but understand that this is a specification tree and this is a model space. Sometimes what happens for a beginner is they will by mistake click over here on the stem, and the color changes to some kind of a dull color, and if we try to rotate or something, it's just gonna mess up our specification tree and nothing happens to our model. So that's one thing over here. Even if you try to pan it, it's just nothing's gonna happen, except that the specification tree is moving. If you just try to move it around, you can see that specification tree is moving. So you can understand that you can switch to the specification tree mode by clicking on the stem, and we use the same method to come back to the model. And now this is what happens. Now we need to put it back. You can also click and move, and it just goes back to the original space. Or else, if you would like to do the other way, just click over here. You can always move it, or you can just move it using the right click as well. So you'll understand that once you spend a little bit of time on this. Let's just move ahead with the specification tree and toolbars. Now this is a kind of a definition that I myself have written. So let's get into the definition. Before that, we'll just see what a specification tree really means. You can see that there are a lot of products over here, and inside the product you have a couple of parts. Maybe inside this product also we could have had multiple parts or multiple products. So this is like kind of a chain. So a product can accommodate n number of products or n number of parts. So inside the n number of products, they can have n number of products as well. So that the list goes on and on like that. Now let's see what is the specification tree over here. Now if you just try to make this big, you can see that there are a couple of parts over here. So whatever is related to the screwjack body will be created inside this. So nothing's going to be created in any other part. So that's important. Now another thing is, let's say that edge fillet 2. We would like to see that what are the dependencies based on edge fillet 2. what you gotta do is you gotta double click on this part so that the whole tool system or the whole tool list over here changes. If I just put your attention over here, and if I just double click over here, you can see that the whole tools over here got changed. So now we are in the assembly mode, and if I just double click over here, then we are moving to the part mode. Now if we just go over here and let's see what is the parents and children, or what are the dependencies on edge fillet. If I just right click over here and go for the parents and children, note that you can see the parents and children of a feature only if we are inside the model. Now you can see that edge fillet is dependent on the shaft. Now if I do something with the shaft, the edge fillet is going to get affected, and they're going to ask if I want to disable the edge fillet or if I would like to delete it. So that's one important thing over here. So what I've written is, it is a systematic structure that contains 3 data which are linked to one another and stored in various features specified by the user. So this is it's a systematic structure, right? And it stores 3D data. It also stores 2D data as well. Now, which are linked to one another and stored in various features specified by the user. As I have mentioned over here, if I just try to go for parents, these things are linked always. Exceptional cases are maybe they are the initiator geometry. In all the other cases, there will be some kind of a dependency with one another. Now that's that. Let's go back to toolbars. Now these are all the toolbars over here. You can see that if I just move around, you can see that these are the toolbars, and you can rearrange them. You can click the shift key and make it horizontal, and if you would like to place, or if you would like to get them over here, you can always get them over here. And we can always remove the toolbars which are not really required, so that we will have space for the toolbars which are required. You can see that this toolbar is over here, and I don't think I would really use this toolbar, so I would just go for close. Or if I would like to delete or close something else, you can really see that FX and all those things are very rarely or minimally used. But this one, this toolbar is pretty much used, and maybe this one is not much used. So you can modify the toolbars based on your taste, and you can do that. Now this is also not much used, so we have a couple of space where we can actually insert the tools which we really require. Alright, now checking parents and children of a feature. So as I mentioned, if I would like to check the parents and children of edge fillet, I can always go for parents and children. It will be showing what is the dependency. If I would like to see the parents and children of the shaft, I can see that by right clicking and doing that once again. And if I would like to see the parents and children of this sketch, I can still see it by seeing that. You can see that XY plane. There won't be any parents and children for XY plane. No parent, but children definitely will be there. But parents, no. Alright. Now you can see that checking constraints over and under constraint sketch. Now let's go back to the model. You can see that the sketch of the shaft over here. You can see that all of these lines that are involved over here are all green. That means that the sketch is fully constrained. What will happen if I delete one of them? What will happen if I just delete this? You can see that this line is not constrained anymore. Now let me just try to check what was the constraint before I would modify and mess up the model. You can see that 70. So I just remember 70. Now I'll just delete this, and you can see that it's not constrained anymore. Let's just analyze a case where we have constrained everything and this line still is white color. So it is a common practice that we always see before exiting a sketch, that the sketch is fully constrained and we have a color green. And if at all we have a color white, just try to pull them around, and you can see that this is still moving around. Okay, we don't want something that moves around always. just go for 70 over here, and that particular dimension is fixed. I would like to also show another example for under and over constraint sketch. So for that I would like to go ahead and create a sketch. I'll just take a plane and go for the sketch. In this case, what I would do is I would just go for the profile tool. Now we have a profile tool here, right? Now I will go for like 60, 70, and 80. You can see that the sketch is horizontally constrained, but for your clarity I'm just going to constrain it vertically as well. 20, 30, and 40. You can see that the sketch is fully constrained, right? Now what I would do is I'll just delete one of these constraints. So for example, this one. I'll delete this constraint over here, and you can see that immediately two of the lines over here are not constrained anymore. You can see that this is not constrained and this is not constrained. Now let's say I'll go back. Okay, I'll go back. Okay, I'll just delete this. Now let's say that I want an extension of 20 over here. That means that this need to move a little outside. So if this was not constrained, and if I would go for maybe yeah, if I would like to get another 20 over here, what I would do is I would extend this like another 20, that is 100. If I do this, two things can happen. One is that the length will get increased on this side, or it can also remain the same and this length will go inwards. So that's the reason, that's one of the problem that happens when you do a under constraint sketch. So in certain cases, in some companies, what happens is the person does some modeling of some kind of a concept, and in that case he wouldn't have constrained the sketch properly, and he would have changed the company, would have gone. Now the next guy comes and do some enhancements. At that time he wouldn't be aware that this is something that needs to be fixed, and he would make some changes over here, and what happens is we don't really get a desired result. This length goes back and it just changed the complete shape of the model, and maybe at a later stage when it goes for the customer, they realize that the model has been, or the model specification has been completely changed, and that creates a problem. So this is one of the problem that is faced if you are not doing a constraint sketch or a check on the constraint sketch. Now moving forward, inserting a component assembly. Now let's go for, we already have C1 screw jack being inserted. Now let me insert C2 screw jack. Now we also have a C2 screw jack. I'll exit from the sketch. You can see that C1 screw jack, the length over here is 185. Let's see what is it for C2. If it's not 185, then we will change it to if it's 185, then we'll change it to something else, so that we'll have two configurations. So it's 185, so I'll just change it to 105. Note the changes in the model. You can see that this is moved, but all this assembly has not moved along with it. Now I'll double click on the assembly and I will update, Control U, or I'll just press on this button. You can just put your eye over here to see the changes. You can see that the whole assembly moved upwards because I had given a contact constraint between this body and the nut component. That's all. Now moving forward, we'll see how we can insert a component to an assembly. You can see that we have C1 and C2 assemblies over here, and we'll just go for a new product. And as we open that, just go for tile vertically, and then we will insert C1 screw jack, and C2 screw jack over here. As we insert that, we'll be able to see that there is change between the first one and the second one. Imagine a case where the team is working on a concept model, and you want to understand what's the difference between the first delivery and the second delivery. You can easily see that by just right clicking over here, going to the properties and changing the graphic property to red color over here. You can see that it changes to red, and just go for this one. You can change it to some kind of green. So red and green are two contrasting colors or contrasting colors. So we can easily see that the red colors, there are certain places where both are the same. You can see that they are just the same over here, but as it moves upwards, you can see that there are some changes over here, which is visible in the colors. So this is about superimposing the model and verifying or understanding what are the changes that has been done between versions. We have covered the changing graphic properties, inserting a model to an assembly, superimposing identical models. Now we'll see how interference can be checked. I'm just going to open another we're just going to open this that I've prepared a product where we have a couple of pipes and another pipe that is intersecting, so that we can check the option over here. Okay, and you can see that this pipe over here intersects with all of these pipes, and all of these pipes are in different products. Now to do a clash check, what I can do is go for the clash tool, and what you can do is just go for between two selections, select the road as a first selection, go for the selection 2 and select 1, 2 and 3, go for apply, and you can see that the clash between each component is seen separately in a window. So you can always go for this, and you can see that what is the clash distance, even that has been shown. Similarly, as we click over here, you can also see the clash between each component. If I just click over here, it's showing the next clash. So all the clashes are seen simultaneously. You can see it in the overall view over here as well. So this is pretty helpful when we are working with a larger assembly where we really have to take care about the clashes. Now we'll just see what's ahead. Now taking a section view. Now you can see what you can do is you can go for the section tool, and go for positioning and position the section with respect to this plane over here, and just try to move this around like this. We'll place it where we have that flash, or we'll place it over here, and we'll go for definition and go for the section, and you can see that there's clearly a clash over here. Now let's just go for OK, and that section view will be saved. So similarly we can create multiple section views. If I just hide this, you can see that the view is full, and I can create multiple section views. Positioning section, oops, I need to go for this definition section view. So now let's just think of this section as an important section. For example, I would just go for this, and I would make a kind of an inclination. Maybe your manager wants to see your model always from this particular view. So you don't have to create this section all the time. The sections that you have generated will be remaining in your specification tree. So as you have done the review, you can again hide this, and you can continue modeling your model. And then when you want to check whether that some requirement has been met, and if you would like to see the same section once again, you can always go back to the previously created sketch section, and if you unhide that, you will be able to see that. If I would hide this and unhide this, you will be able to see the section, the inclination and everything remains the same, and that section will be displayed. So these are all the options, or these are all the topics that I really wanted to cover, which are really required for the quality engineer. And what extra I can, if I would just try to run around the presentation once again, and I would like to add some more points which is not being planned over here. Maybe when you're doing a work product audit, what you can also see is, for example, in some kind of a in most of the designs, the customer would have some kind of a specification that you should be following this kind of a material. So how we can see that the team has really followed the material? For example, I would just add aluminium to this rod over here. Now this rod is made of aluminium. Now it's not required that we will be using the same aluminium properties that the customer will be having. So how we can define that is going to the properties, and now you can go for analysis, and you'll be able to see the different properties of this aluminium. If you would like to make some changes, you can make some changes over here. So while you're doing an audit, you'll be able to see, you can ask the customer requirement or the customer standard that we received, what the poisson the density of the material, and you can open this properties, and going to the analysis, you will be able to see whether the team is really following the material properties that the customer defined, and if it's not, it's not really a compliant way of designing. So that's one thing, that's one more thing that you can do. And main thing that any person who's really reviewing the model, what they have to understand is how the way the specification tree works, and also understand that each model elements will be all prepared inside that particular model. So this is how it works. Assembly, inside assembly it could be a part of a product. If it's a product, then inside that product there could be parts or multiple parts of products, and that's how the assembly tree works. And this is how it can be expanded or contracted. And that's all about this session. And if you have any questions, you are always welcome to ask me. And that's all. Thank you so much, and stay tuned.